All right. Good afternoon again, everybody. So today we'll look at let's see. Got it. And then here. Okay. So last time we're talking about classification algorithms, right? Which is a form of supervised learning. And then we look at ano ba yung mga tinignan natin? We look at KNN clustering. We look at Bayesian or Bayesian clustering and decision tree clustering. KNN classification, naive Bayesian classification, and decision tree classification. So you already have a pre-group or a pre-clustered set of data, and then you'll train your model to classify as a query point into one of the clusters inside your data point, right? So ginawa natin, hiwalay tayo nagsulat ng code. Oh, by the way, I'll share with you the snippets of the codes that we used last time para mapaglaruan nyo siya. Medyo lilinisin ko lang siya ng konti, pero I'll upload it later. So you have, this is for, what is this? This is for the naive Bayesian grouping, all right? Tapos ito yung sa decision tree algorithm, and then ito yung sa KNN. Now, we said that if you want to see which one is best, you can do a cross-validation. And we did a cross-validation. Actually, minano-mano rin natin siya. Which one did we use last time? All right. So here, like in the naive Bayesian classification routine, gumamit tayo ng cross-validation using 30% of our data as our test data and the 70% to our training data. And this is useful whenever you want to decide what type of classification algorithm to use and what type of parameters will be fed into those algorithms. Because kapag nakapili ka na nga ng isang classification algorithm, you need to decide kung ano yung mga parameters dun sa loob, like what type of distance you want to use, how many neighbors you want in the KNN algorithm, and for instance, what probability distribution you will use for the naive Bayesian algorithm. All right. So marami pa rin questions. So you have to look at it. And yun nga, cross-validation, we usually create a confusion matrix for our classification routine. Tapos we take note of the accuracy, call it the score of our algorithm, and probably one thing that you can do, compare the scores. And the one with the highest score will be the one that you're going to use, right? Pero mano-mano natin siyang ginawa. Now, I discovered while tinkering around Matlab that Matlab has the classification learner. So I think if you install the statistical and machine learning package, so you will see here, by default kasi nasa editor tayo, click on the apps tab. Hold on. Okay. Click nyo yung apps tab na narito. So click that, and then you will see a list of apps that you can use. And then you can click on the classification learner app, and then something like this will pop up, right? Where is that? Hold on, ayaw niya mag-pop up. Where is that? Yeah, classification. All right. So I have my classification learner here. Dami kasing bukas na tab. All right. So itong classification learner, this will give you access. This application will give you access to all of the available learning algorithms or classification learning algorithms in Matlab, yung mga intrinsic niya. And here you can optimize and find the best parameters for each of the methods para hindi ka na gagawa ng confusion matrix para sa kanilang lahat. Kasi ang gagawin niya, halimbawa, titingnan niya sa lahat ng posibleng KNN. Ano dapat yung parameter na K? Remember, there's no a priori way of computing K. Our rule of thumb is to use square root of the number of points para sa ating value ni K. Pero ang problema, hindi lagi yun yung optimal. Wala tayong formula para sa optimal value ni K. So usually, what we do is we train, we run the model, and then find the best K. So pwede nyo gawin. Pwede kayong mag-confusion math, mag cross-validation for different values of K. mano-mano, gawin nyo to, take note of the score, look at the confusion matrices for different values of K, record the scores, and then pick the best score and use that K value. All right? Pero medyo matagal siya. Pero si Matlab, pwede niya itong gawin on its own. Meron na siyang routine. Meron na siyang app na gumagawa nito. Well, the first thing pala is, before I go there, let me load muna yung aking data set. So let's look at the Fisher-Irish data again. So I'll highlight it, I'll press F9 so that the data in Fisher-Irish, which consists of our 150 by 4 matrix consisting of 150 specimen and 4 attributes, and then yung species list, right? So sorry, medyo maliit yung nandun sa right-hand side, yung workspace, pero I hope you can still see this, right? So niload ko siya kasi pagbalik ko dun sa application, sa classification learner application, I can click start on a new section on the top left, and then, come on, click. Right. Click new session, and then I will load the data from the workspace. Kaya importante na na-load mo na yung data dun sa workspace. Right. So ito, pipiliin ko na. So data set variables, so measurement. Makita nyo, measurement. Ito kasi yung data consisting of the measurements that we have. Ito yung gagamitin natin pang train ng ating algorithm, right? Tapos, wala, ba't hindi siya, okay. Hindi ko nasulatan sa ibabaw. And then, yung response, piliin nyo siya to be something from the workspace. Kasi yung response natin nakahiwalay dun sa dataset, alright? So yung measurement matrix, yung MES matrix, 150 by 4, lahat sila, ang laman niya ay mga measurements. Hindi dun kasali yung response o yung classification natin. So yung classification, which the application calls response, ay nasa species na cell or na structure. Kaya i-load ko siya sa response from workspace, then species, and then I'm gonna start session. So medyo maglo-load lang yan ng konti. Okay. And then once the data are loaded, by default, iraran na kagad ng application learner, anong classification learner app, yung decision tree model. Right? So niran niya to, makikita niyo sa left pane, lahat ng models na ginagamit niya. So finit ko lahat ng data. So by default, tinrain na ni Matlab. Maybe I should click here. So train ko to. I'll click the train button here. Pag nakapili na ako ng model, click train para i-train na ni Matlab yan. Okay, let's just wait for Matlab to train this. So ibig sabihin, niraran niya na yung decision tree algorithm, right? So makita nyo rito yung result for model 1. That's our model 1. Okay. Naka-on yung parallel computing just to handle large data. Dapat in-off ko siya pero doesn't matter. 150 lang naman yung data ko. So supposedly, hindi ko pa kailangan lahat ng CPU ko. Pero sa simula lang naman siya matagal mag-run. So you see here, the Matlab is training the decision tree algorithm, creating a model for the classification. So let's see. Okay. So pag niran nyo pag tinrain nyo na yung data, so makikita nyo dito yung summary, model parameters, so yung accuracy niya from cross-validation. Oops. What's happening here? Hold on. Kita nyo yung accuracy niya sa cross-validation is about 96.7%. And then makikita niyo yung model hyperparameters. So ang ginamit niya ay fine tree, merong 100 splits, etc. And then here's the scatter plot. Makikita niyo yung model predictions at saka yung mga tama at mga mali niyang na-predict. So ibig sabihin, in the cross-validation, Matlab or this tree algorithm, the fine tree algorithm, properly characterized yung mga nakadot, right, as setosa, versicolor, at saka virginica, pero it failed to classify those with an X correctly, right? So at least now, pag niran mo yung tree algorithm, okay na to, all right? So pwede mong i-note yung kanyang results. And then one of the tabs here will tell you the validation, or will show you the validation or the confusion matrix. And you see here, dito nakuha yung scores. So ibig sabihin out of 50, 47, and 48, and then 5. So medyo lima yung mali niyang prediction out of how many? Out of 150, right? So ginawa niyang pang-validate yung buong data set, right? Then this is by default, nilalabas yung confusion matrix. You can also look at this, the plot and interpret group dun sa dun sa ribbon. Click niyo yung ROC curve validation. Okay. So this is, ano nga ibig sabihin ng ROC? This is the receiver operating characteristic curve na magpapakita sa atin ng plot ng false negative results at saka ng true positive results. So false positive rate and then true positive rate. Sorry, not false negative. False positive rate and the true positive rate. Plot niyo yan using the different decision thresholds. Okay? So maganda yung pagkaka-predict niya sa setosa. So walang error dun sa setosa kasi 0% yung false positive, tapos 100% yung true positive, of course. Pag tinignan mo yung versicolor, you just click here on the right pane sa versicolor, papakita niya yung para sa versicolor. It's not, hindi siya kasing ganda nung sa setosa because there are some false positive responses, right? So the threshold here is 90.2%. Tapos ang kanyang true positive rate is 94%. And then Virginica, you see here. Okay. Ito rin yung kanyang ROC. Now, we didn't discuss ROC as a decision parameter or as a validation tool. Confusion matrix lang yung nagka-time tayo to discuss last time. But I invite you to read on ROC and how it is used to validate or to validate your results. Ano? Kasi akala ko noon mahirap gumawa ng ROC kay Matlab ng mano-mano, pero ito pala, meron siyang application that will output it right away. Okay? What I love with this application, hold on. Okay. What I love with this application is pwede akong mag-train ng iba't ibang mga data and I don't have to feed all of the parameters, right? So for instance, if I go here, okay, punta ako dito sa models na tab ng ribbon, I can click the drop down and then I can choose among all of the possible classification models. Halimbawa, naive Bayesian classifiers. So you have the naive Bayes, kernel naive Bayes, all naive Bayes, optimizable naive Bayes. So tingnan natin yung Gaussian Bayes. So click on the Gaussian Bayes button and then naive Bayes will be loaded as model number 2. So tingnan nyo to, nasa model number 2 na itong main pane. Right, model number 2, papakita nyo yung summary. Naka-draft pa siya kasi hindi ko pa tinetrain, right? So I can just click this play button para i-train ni Matlab using the preloaded measurement matrix, yung naive Bayesian classification routine. So it will run. Okay, so training siya. Kita nyo rito, loading siya. And the accuracy is around 94.7%. Now, it will automatically output the confusion matrix. So meron siyang 8 missed classifications. Right? And then if you look at the summary, click on the summary tab here under module number 2, makikita niyo yung model hyperparameters. So gumamit siya ng Gaussian distribution. So that's the only option that we have, or the only parameter that you need to feed to naive Bayesian. All right? So yun yung result niya. Kaya lang, hindi ko alam na kung naive Bayesian nga ba yung best. Ano? So pwede kong i-click itong optimizable naive Bayesian para titingnan niya ano yung pinakamaganda among the options available. Because here in A Bayesian, you can select what type of probability distribution you will use, either Gaussian, kernel, or all other distributions. So, kasi di ba dun sa options, kapag ka ginamit natin yung fit C and B command kay Matlab, pwede tayong pwede tayong magdikta kung ano yung probability distribution na gagamitin. But how do we know which one is the best? Well, one way, i-run mo siya, paglaruan nyo siya, tawagin yung iba't ibang probability distribution, create a confusion matrix for all of them, and then compute the scores. And the one with the highest score, siya yung tatawagin nating optimal probability distribution for the naive Bayesian classifier. Pero medyo matrabaho yun, no? But this application can right away decide for us kung ano yung optimal parameters. So you just click on optimizable naive Bayes. Okay, so ilo-load siya as the third model. So nasa model 3 na ako. Look at my cursor, model number 3. Here's the summary. So pwede mo sabihin sa kanya kung ano yung mga hyperparameters o yung mga problem parameters na gusto mong i-optimize niya. If you want Matlab to decide what's the best distribution and what's the best kernel type, so ira-run niya to. All right. So you just need to click train. Tapos hanapin ni Matlab ano yung pinaka magandang hyperparameters. Ang tawag niya hyperparameters, pero pwede mo naman tingnan na sa parameter lang, ano? So Matlab is currently training the naive Bayesian while searching heuristically for the best parameters in the problem. Pinipili niya yung probability distribution that will best classify the data and the best kernel na gagamitin niya para dun sa probability distribution. Medyo matagal pala to. Hold on. Hindi naman to ganito kabagal kanina. Let me just close ko muna yung iba kong mga tabs. Okay. Okay, while waiting, do you guys have any questions so far? Have you seen this before? Kasi na-amaze ako, ngayon ko lang siya nakita. After kung gumagamit ng Matlab for 7 years or so. Ngayon ko lang siya nakita. Okay, so I think we are done. So the accuracy is 96% based on the cross-validation that we had. This is the confusion matrix, okay? And then minimum classification, okay. Then go to summary to see what was the model parameters that were used, okay? Now, all right. Nakita niya rito na if you look, I don't know if you can still see it, so maybe you can pinch on your screens para makapag-zoom in kayo dito sa model hyperparameters na yan. All right. So Matlab found out that the best parameter here, insofar as distribution or probability distribution is concerned, kernel dapat daw yung optimal mong gamitin. And the kernel type was chosen to be triangle, right? Ang mga pinagpilian niya, Gaussian distribution, kernel distribution, tapos ito yung mga pinagpiliin niya for the kernel type. And out of these options, yung kernel triangle pair, pinakita niya to give us the best results. Okay? And then you can do this for all machine learning algorithms here insofar as classification is concerned. You have decision trees, discriminant analysis, support vector machines, which is also a popular technique which we don't have time to discuss. Tiningnan natin na yung KNN last time. So sige, i-load ko yung KNN. Tapos click ko yung optimizable KNN. Sana mabilis lang din to. Alright, so Matlab is pre-loading KNN here. Pero sabi ko sa kanya, optimizable para siya yung maghahanap. Ito yung mga hanapin niyang parameters. Number of neighbors, di ba? Ang ating ang ating ad hoc value ay square root of the number of the floor or the ceiling of the square root of the number of data points, right? And then siya rin yung pipili, ano yung tamang distance metric? Ang ginagamit natin dati ay what? Euclidean distance usually yung ginagamit natin. Tapos distance weight, and then it will check if it really needs to pre-process the data. Yun yung kagandahan dito. Siya na rin yung magde-decide kung kailangan pa bang i-normalize yung data. So let me train the model and see what we get. Right. Medyo marami-rami to, pero I think naka-queue na siya. It is running. Okay. It's good pala na in-on ko yung by default kasi naka-on yung parallel processing nito. So if your computers or laptops have 4 cores, so naghahati-hati yung 4 na cores o 8 cores ng computer nyo in doing the work. All right. Maganda sana kung may server tayo sa math, para sana mag-run ako ng Matlab dun sa server. Depende sa number ng CPUs dun sa server natin. So mas mabilis sana yung computations. And I can run that from a remote machine. Mag-run siya sa server na nasa math building. Pero hanggang ngayon, pangarap pa rin siya. Medyo mahal kasi. Hindi kinakaya ng budget. Okay. Now, tapos na yung KNN na pagtitrain. Let's look at the summary. Okay. In the summary, let's see, 98%. I think this is the best validation that the best model that we got with respect to cross-validation. And you see here are the parameters that it found. Okay. 24 pala yung nearest neighbor na pinaka-magbibigay sa atin ng pinakamagandang result. And this is what surprised me when I was running it earlier. Cosine distance yung pinakamaganda. Samantalang last meeting, nilait-lait ko yung cosine distance kasi parang hindi naman siya yung magandang measure. That could probably be the case because last time I was just considering 13 neighbors. I think it was the ceiling of square root of 150, right? Tapos cosine distance, hindi kagandahan yung nakuha nating results. Pero when I asked Matlab to heuristically optimize the model, nakita niya, pinakamaganda yung cosine, pero dapat 24 yung neighbors mong gamitin. Okay? Tapos nakikita nyo rito, ito yung mga pinagpilian niya. And out of this parameter range or parameter domain, ito yung nakuha niya na best parameters. Okay? And then of course, you can go to the validation matrix. If you want, you can look at the scatter plot as well. So you generate the scatter plot. So doon na ako nag-click sa plot and interpret ribbon. Okay. So you see here a 2-dimensional plot of the observation, their classification, and whether or not our model got it right or got them right. Tapos pwede mo ring palitan yung sa predictors. Remember, niload ko yung buong MES matrix. So, pero 2 at a time lamang yung nadi-display niya na variables. Column 1 is sepal, I think, sepal width. And then column 2 is sepal length, or the other way around. I just forgot. Tapos yung huling 2 columns ay para sa petal measurements. You can play with it. And then, by just doing this, and then changing the parameters, and then you will see the different dimensions of your data, or you will see slices of your data 2 at a time, right? So ito yung paborito kong view, yung column 3 and column 4. Okay, kasi parang dito ko mas na-visualize yung itsura ng data. And after reconsidering this, now it makes sense that when I'm using more neighbors in the KNN search, mas maganda nga yung cosine kasi parang ang behavior lang naman ng data ko ay along a straight line. So parang gumagawa lang ako ng thin slice along a two polar lines para doon sa region kung saan maka-classify ko na siya ay viscosa, versicolor, or virginica. Right? Now you can run everything. You can also click all quick to train para ilo-load niya lahat, mag-optimize siya lahat, gagamitin niya lahat ng possible models sa kanyang library, tapos pipili tayo mamaya kung ano yung pinakamaganda. All right? So, but I will leave the exploration of the app to you, all right? So siguro tingnan natin yung results table. So if you click on the results table found here in the still in the main ribbon, click on it. Isa-summarize niya yung mga natutunan niya mula dun sa 4 na models na nirun natin. Remember, we run the 3 algorithms, the NJAE base, the optimized NJAE base, and the KNN, optimized KNN. And here we can compare which one performed best in the cross-validation. And it seems here that KNN was the best one, right? So ito yung pinakamaganda. So what I'll do is probably click on KNN, right? Tapos, kung gusto ko itong gamitin sa aking code, right, pwede ko itong directly i-export papunta dun sa aking Matlab workspace. Right? Hindi ko na kailangan mag-generate ng code on my own. So na-train ko na si KNN, nahanap ko na yung pinakamagandang parameter sa kanya. All I need to do now is to export this model into my workspace. And I'm gonna use the export model button. Click on it. Tapos, tatanungin ako ni Matlab, export the current trained model to a variable, to a workspace variable name. Pwede kong palitan, pero sabihin natin ito yung best model. And then click OK. And then that should divert me back to Matlab, to the main window. Okay. Garan pa ba siya? Let me see. Okay, there we go. So na-export na ni Matlab into my workspace yung best model. Yan ang galing doon sa classification learner. Click on the best model structure here to see the model parameters that we generated. So you can further click on classification KNN, which is basically our model. Makikita nyo dito yung model parameters. You have 24 neighbors, the cosine distance was used, the weight is inverse, you break ties using this. The method for finding the nearest neighbor is exhaustive search, and so on. So yan yung mga parameters yung ginamit. And then, nandito sa, makikita nyo sa workspace, dito naka-specify kung paano tayo magka-classify, right? So meron na siya dito sinabi, to make predictions, use this function, right? Yan daw yung command para maggamit natin yung best model na in-export natin from the app. Okay? So hindi na natin kailangan pala itong knn.m na tinype ko last time, mano-mano natin itong inanalyze, nag-knn search tayo ng hiwalay, tapos saka tayo nag-prediction, alright? Actually, mano-mano pa dito yung prediction ko, pero pwede pala akong gumamit ng predict command. Pero ngayon, ito na yung gagamitin ko, best model. Okay. Copy-paste ko siya dyan. Oops. Tapos, maglagay lang ako ng query points, right? So, ano kaya ang pwede nating query points? May query points ba tayo rito? Let's see. Okay. Halimbawa ito, siguro gawin nating dalawa. Yeah. Maybe I'll use this as my query points. So, query points ko to. I-feed ko lang siya to the best model that predict function. Okay? So, ibig sabihin, ita-try niya i-classify ito at saka ito. Right? So, let's call this our prediction. Our prediction equals that guy. Press enter. Oops, what happened? Sorry. Nawala yung starting bracket. Kasi dapat vector or matrix yung i-feed nyo. I am feeding it a 2x4 matrix, meaning I have 2 specimens that I want to be classified and I have all 4 measurements kasi tinrain natin yung model using 4 measurements. Okay. And then here are the outputs. The first specimen was classified as Virginica. Ganun din pala yung pangalawa. Virginica rin yung kanyang classification. And in this manner, you see, we have a nice way of finding what's the best algorithm. Hindi nga lang best algorithm or best model for our data. Nahanap rin natin yung pinakamagandang parameters, yung pinakamagandang model para dun sa ating data. Right? Ang dami ko sanang oras na na-save kung natutunan ko na to before. Kaya buti na lang, nabudol ako na magturo ng 255, natutunan kong gamitin, na-discover ko itong command na to or itong app na to. All right? So don't worry, in the problem set, you will have your chance to play with this. All right? Kasi mamaya, di-discuss ko yung problem set number 3 ninyo. Okay? So any questions? Off ko muna yung Matlab. Pabalik ako sa notes. Okay, let me share my screen. Oops. Sorry, hanggang ngayon nangangapa pa rin ako kay Zoom. Okay, so now we'll jump to the second part of our program. Titingin naman tayo sa classification algorithms. So, classification algorithms. So this is a type of unsupervised learning. Unsupervised. Kung na ito susulat. Unsupervised learning in the sense that you will just be feeding a bunch of data that you know possesses some groupings or clusterings, and we will let not classification. Sorry, take 2. Clustering. So we'll be looking at clustering algorithms, which is an unsupervised machine learning process wherein we will feed into our model a set of measurements that we know to be which we know to be classifiable under some clusters or some groups or some classes. Kaya lang kaibahan niya dun sa data na feed natin dun sa classification algorithms, dito hindi natin alam kung sino yung magkakagroup. We will train our model or our machine to discover the pattern among the measurements or the attributes that we will pass on to it, tapos siya yung magde-decide sino yung magkakagrupo. Right? Kaya siya unsupervised. Because other than the measurements, we will not give Matlab any other information. We'll just sit back and then we will let the machine learn the thing for us. And then pwede na natin gamitin yung lalabas dun sa clustering, probably in a classification algorithm. Okay. Now, there are of course, there are lots of clustering methods, right? Pero ano yung ideal na gusto natin with the clusterings, right? So we want the clustering to be as compact as possible, and the clusters to be as compact as possible, and the clusters to be as far apart from each other. So yun yung gusto nating ideal clustering. Girl, let me take note of that. So the clusters or the classes, tawagin ko na lang siyang classes, are as compact as possible. Meaning dapat yung mga members nung mga classes o nung mga clusters natin ay magkakalapit sa isa't isa. But how do we measure magkakalapit? So depende yon sa distance metric na ipapasa nyo dun sa model, right? So the classes should be as clustered as possible or as compact as possible. Dapat magkakalapit silang lahat. And at the same time, the clusters are as far apart as possible. So dapat magkakalayo. Yun yung ideal. Dapat magkakaiba yung mga clusters so that you have a distinguishing characteristic among the clusters or pronounce yung pinagkaiba ng isang cluster from the other. So we're assuming here that the members of our clusters are homogeneous while the clusters are heterogeneous. So yun yung parang idea rito. And to measure these things, we have 2 usual indices or metrics na ginagamit para i-measure yung pagiging maganda ng ating clustering algorithm. The first measure is what we call the inertia. The inertia measures how far the points within the clusters are. Or basically, this is what we can think of as the intra-cluster distance. So usual ways of computing the inertia is we're taking the sum of the distances of points x from a fixed point x tilde, right? X tilde is what we call the centroid or the mean or the average of the cluster. And we're taking the sum of the distances over all members of a cluster C. So kung meron kang cluster C, computein mo lang yung distance ng bawat member ng cluster from the central element, which we call the centroid of our cluster. Then the sum of those distances is what we call the inertia, right? And this is a measure of the compactness of the clusters, right? And so that means we want what? We want the inertia to be as small as possible, right? Gusto natin maliit lang yung value ng inertia para ibig sabihin magkakalapit yung mga points natin sa cluster because they are all within a small neighborhood of the centroid, so that means they are compactly embedded inside one open ball or an open sphere, right? So yun yung inertia. Ang problema, yung characteristic number 1 lamang yung mini-measure ng inertia. It's a nice measure. Siguro pwede natin itong gamitin when we measure something or when we design our algorithms, pero hindi niya natitake into account kung gaano yung pagkakaiba-iba sa pagitan ng iba't ibang clusters, right? And so that's why most people, instead of the inertia, they use the Dunn index. The Dunn index is basically is a measure or is the ratio between the minimum intercluster distance over the maximum intracluster distance. So basically, this is, let's call the Dunn index, say, D. This is the minimum intercluster distance over the maximum intracluster distance. So basically, you can think of the Dunn index to be one score for a model or for a clustering algorithm. So ang gagawin mo rito ay, kukomputin mo yung minimum intercluster distance. So say you have divided your data into 3 clusters, C1, C2, and C3. You will compute the inertia, right? You will compute the inertia, not the inertia, but you will compute the intercluster distance. Numerator pala muna. Minimum intercluster distance. So how far is C1 from C2 and C1 from C3 and then C2 to C3. So you will compute these 3 distances, but how do we compute distances between clusters? Well, mamaya bibigyan ko kayo ng iba't ibang posibleng ways to measure that distance, all right? Divided by the maximum intracluster distance. So yung denominator siya yung maximum inertia. So kukomputin nyo yung inertia ng C1, which is basically the sum of the distances of the members of C1 from the centroid of C1. Inertia of C2, inertia of C3, you pick the largest, you put that in the denominator. When you compute the Dunn index, this is a single number. This is a scalar that will sort of give us a measure of how well the 2 characteristics or the 2 ideal characteristics of a clustering are satisfied, all right? So basically, we want the Dunn index to be as high as possible. So whenever you're comparing clustering algorithms, you can compute their Dunn indices, and then the one that will give you the highest Dunn index, siya yung pipiliin yung clustering algorithm, right? Pero matrabaho kasing computein yung Dunn index. But quickly, let's understand mathematically why it makes sense for us to maximize the Dunn index. To maximize the Dunn index, we want the minimum intercluster distance to be high. Right? Para malaki yung value ni D, dapat mataas yung numerator. So that means the minimum intercluster distance is high. So ibig sabihin, magkakalayo yung bawat cluster. And then to further maximize D, we can set the denominator to be very, very small. Right? Because the smaller the denominator is, the larger the fraction becomes. And so that means the maximum intracluster distance is very small. Napakaliit ng intracluster distance, so ibig sabihin compact yung clustering na nabuo natin. Okay? So kaya lang yun nga, medyo matrabahong computein yung Dunn index. Now that leaves us another question. How do we compute the distance between clusters? Pwede natin silang i-measure using what we call the linkage. right? Which is one measure, or this is what we call what we usually refer to as distance between clusters. So distance between clusters. Okay, and then there are several linkages or type of linkages. Pwedeng una ay single linkage. The single linkage is basically the distance between nearest neighbors between clusters, right? So let's say, sige na, sulat ko na lang siya mathematically. So suppose R and S, capital R and S are the clusters in our classification scheme. So yung distance between cluster R and cluster S using the single linkage measure is basically the minimum between among the distances of members of R and S. R belongs to R, S belongs to capital S. So, dinidefine natin dito yung distance sa pagitan ng dalawang cluster to be the distance between the nearest neighbors, one coming from cluster R, one coming from cluster S. So, ito yung tinatawag na single linkage. Now, you can also do a complete linkage wherein the measure we give or the distance we assign between two clusters is not the minimum, but the maximum distance. So basically, i-measure natin gaano magkalayo yung farthest neighbors between the two clusters. So you get the maximum of this set of distances. So yun yung complete linkage. Of course, these are two extremes. You get the minimum, you get the maximum. You might also want to take the average linkage. The average linkage, as the name implies, ito lamang yung average ng mga distances. So you take the sum of the distances. Magiging double summation to kasi kukompute natin to sa bawat isang element ng dalawang cluster, and then we take the average. So we multiply it by 1 over the size of R and the size of S. So ito yung average linkage. Now, these three matrices or these three types of linkages are very expensive to compute, especially if you're working with large data. Kasi kinocompute mo rito bawat isang distance at kinocompare mo silang lahat. In the case of the single and the complete linkage, tapos ina-average mo sila dun sa average linkage. Now, you can also just take a look at the centroid linkage. The centroid linkage will simply assign the distance between clusters to simply be the L2 distance between their centroids. Halimbawa, si X tilde R, yung centroid ni R, si X tilde S, yung centroid ni cluster S. Kunin mo lang yung distance sa pagitan ng mga centroids, yun yung tatawagin nating centroid linkage. Pwedeng ito yung gamitin nating distance between two clusters. Okay. Ano pa nga ba yung isa? Actually, may dalawa pa. Sige, bigay ko na lang sa inyo lahat para kompleto yung information nyo. No? We also have what we call the median linkage. Well, the median linkage takes into account, actually ginagamit to usually kapag itong median linkage, kapag gumagamit ka ng hierarchical clustering. Ano? Kasi sa hierarchical clustering, iterative yung process. Meron ka mga sub-clusters, right? So, bigyan ko to ng asterisk. Usually sa hierarchical clustering siya. So, ang ginagawa niya, ang distance between two clusters is basically the L2 distance between weighted centroids rather than the actual centroids themselves. So, pwede ko itong tawagin X tilde R minus X tilde star S. Kukunin ko yung L2 distance where X tilde R is basically the average between the centroids of two smaller clusters that comprised the cluster R. So, ito yung itsura niya. R1 plus X tilde R2, assuming that R was obtained by taking the union of two previous clusters. Sa isang agglomerative hierarchical clustering, makikita natin to later, kasi ang ginagawa niya paunti-unti siya nagka-cluster. Alright? So, kapag ka meron kang isang cluster na nabuo by the union of two smaller clusters, kinombine mo sila to make a bigger cluster. Alright? So, pwede mo computein yung two previous centroids, take their average, and call that average to be the weighted centroid of the set R or the new cluster R. Tapos siya yung gamitin mo doon sa pagko-compute ng inter-cluster distance. Okay? And that's what we call the median linkage. But this is rarely used. Gamit na gamit lang siya kapag ka hierarchical yung ginagawa yung clustering algorithm. And then the last one, which is perhaps one of the most popular one, at yung Ward's distance or Ward's linkage. Okay. And this is sometimes called the minimum variance linkage, because what it does, it computes the increase in the total intercluster sum of squares. Or basically, tinitingnan niya yung increase dun sa sum of squares of the distances. So parang nasan ba yung sum ng squares ng distances? Sum ng distances ng and the centroid. Actually, hindi ko pala siya define. But anyway, so yung Ward's linkage, so tinitingnan niya yung ano yung magiging bagong distance. Parang criteria kasi to supposedly for hierarchical clustering. Tinitingnan niya ano yung magiging bagong distance kapag ginawa ko ay pinag-join ko yung dalawang cluster. May madadagdag ba or mababawas? So basically, in this particular case, the distance will be computed as the square root of 2 times the size of R times the size of S over the size of R plus the size of S times the L2 distance of observations of the centroids of R and S respectively. All right? So siya yung Ward's distance. So basically, ito yung gano'n yung itinaas nung square, nung sum ng squares ng intercluster distances. All right? So ito yung mga iba't ibang metrics, but of course, we don't need to calculate all of these by hand. Ano? So it would be more important to understand what their interpretations are para pag nakita nyo yung data nyo, alam nyo na, mas okay gamitin yung Ward's linkage or mas okay na gamitin yung complete linkage rather than single linkage or the average linkage. Okay? So, ito yung mga metrics na pwede nating tingnan. And let's look at some algorithms. Some usually used clustering algorithms. The first one is the hierarchical clustering. Excuse me, guys. Hold on. Give me 1 minute. Okay. So the hierarchical clustering is one method that does the clustering in such a way that you can discover yung structure ng data before you go to the actual clustering. So dinidivide niya step by step or gumagawa siya ng isang binary clustering at every iteration ng data, tapos nagko-combine siya ng mga clusters dependent on the kind of linkage that we define para makabuo ng mas malalaking clusters hanggang maubusan tayo ng iterations na kailangan or hanggang ma-attain natin yung number of clusters required. Okay? So for instance, let's look at the graphical implementation of this. Halimbawa, meron akong data A, meron akong B, tapos meron akong C, meron akong D, meron akong E, tapos meron akong F. Alright? So sa first iteration, ang gagawin ni hierarchical clustering ay iti-treat niya bawat isa sa mga data points ko. So imagine nasa 2D lang tayo but extendable naman to in multiple dimensions. Magbabago lang yung measure of distance mo. So una, i-consider niya lahat to be individual clusters. Right? So ibig sabihin at this point, 2, 4, 6, we have 6 clusters. Now, on the second iteration, it will look for the 2 nearest clusters to each other, and they will be combined to form a bigger cluster. So for instance, in this example, if my distance or the metric that I'm using is the Euclidean distance, I am guessing that B and C are closest to each other. All right? So ibig sabihin, at this iteration, I discovered that B and C would be grouped together. Okay? So isa na sila ngayong cluster. Magkasama na sila sa cluster. And the next, so meron na lang ilang clusters. 1, 2, 3, 4, 5 clusters. So susunod na step, ganun ulit. Pipiliin ko ngayon sino yung dalawang clusters na magkalapit sa isa't isa. Remembering that B and C now constitute a single cluster, right? So ibig sabihin, kukomputing ko yung intercluster distance nito, ito, at ito. Alright? I-record ko yan. And then, how do I measure the distance between a cluster and another cluster? You can select from the type of linkages na dinefine ko kanina. Right? So, halimbawa, single link, single linkage yung gagamitin kong measure. So, it's yung nearest neighbor. Pero, in this particular case, I am guessing that, kunwari lang, si D at saka si E yung magkalapit sa isa't isa. Oops, ibang kulay yung gamitin natin. So since cluster D and cluster E are nearest to each other, now in this iteration, they will be treated to constitute another cluster. And then the algorithm will go on, all right? Third iteration, pagsasamahin ko ulit yung dalawang pinakamagkalapit na clusters. So kung gagamitin ko yung yung single link, ito yung candidate, ito yung candidate, at ito yung candidate. Of course, I will not join these two kasi hindi sila yung pinakamalapit. Which one could be the nearest to each other? I am guessing, kunwari lang, kasi hindi naman ako nag-measure, I think cluster BC and cluster DE are the closest to each other. So I'm going to put them under one cluster. Okay. And then I will redo this for the final iteration. Sino yung susunod na magka-cluster? Cluster BCDE, cluster A, or cluster F. I need to pick which two clusters will be combined together, right? Okay, usually yung Ward's link at saka yung median linkage are primarily used for the hierarchical clustering. Okay, so I think I'm guessing here yung huli kong grouping ay eto. Oops, sorry. Let's use a different color. Though nag-mix na yung color ko, hindi ko na makita yung original grouping. But I hope you get the idea. And then the last part will be this one. Okay. Ito na silang lahat. Okay. So you can think of it as an agglomerative grouping in the sense that I start from the bottom up papunta dun sa top nung clustering, right? So you are starting with small clusters and then you are enlarging the clusters. There's another way of doing hierarchical clustering, yung divisive clustering naman na tinatawag, wherein you start at the top, you consider the entire data set as one cluster, and then you find what are the distinguishing characteristics between them, mainly computing the distances, and then you construct smaller and smaller clusters. Okay. Medyo may may drawback ito. Ang advantage ng hierarchical ay nadidiscover natin yung pattern or yung structure ng data within the clusters. Because we can zoom in and look at the clusters and discover there are subclusters in there. Kaya lang medyo mahal yung pag-hierarchical clustering because an agglomerative so ito yung bottom up na clustering, it costs big O of n cubed. Though polynomial time pa rin naman, pero medyo malaki yan, big O of n cubed. While the divisive algorithm is actually much more expensive. It's big O of 2 to the n. Ito yung kanilang worst case scenarios. There are special cases wherein hierarchical algorithms will run faster than big O of n cubed, or the divisive algorithm will run faster than big O of 2 to the n, pero ito yung mga worst cases. Ito yung generic cases. Another drawback of hierarchical clustering is kino-consider niya lahat ng data points. But that's not always good because sometimes we have outliers in our data, right? Meron mga pasaway na measurements, be it due to measurement error, be it due to noise, or be it due to some data collection error, all right? So kapag kinonsider natin yung mga galing sa noise or galing sa measurement error, ang laki ng impact nila dun sa clustering na magaganap, right? So that brings us to another method which tries to eliminate or try to look at what would be or how to eliminate the effect of outliers. Ito yung tinatawag natin na density-based clustering. There are several subcategories for density-based clustering, pero isa na lang yung pag-usapan natin. You can explore the others. Let's talk about the DB-scan algorithm. DB-scan stands for the density-based, density-based spatial clustering of applications with noise. Ito yung DB-scan. So para sa DB-scan algorithm, kailangan natin dalawang parameters na i-feed into our model. So kailangan mag-declare ako ng epsilon. So we need to declare epsilon, which is the radius. Okay. I'll explain later why para saan yung epsilon na yan. And then another parameter, theta, which is basically the density. Okay. And then rough sketch of the algorithm ay ito. Una, sige, sipin ko muna. Paano ko to i-present ng mas maayos? Okay, so probably let's pick an unlabeled or an uncategorized data point X and initialize a cluster C, a cluster C sub I, right? Of course, we'll do this for I from 1 to the number of clusters that we want, right? Okay, actually, kailangan ko bang i-declare a number of clusters? I don't think kailangan ko yung number of clusters, but yeah. But just think of it as naka-initialize muna na I equals 1. So initialize I equals 1. And then at this step, I will pick an uncategorized data point. So marami tayong data points. Pili ka ng isa sa kanila. And then we initialize a cluster C sub I. And then we compute. So we compute the number of elements of the number of elements in the entire data set that are within epsilon units away from the point X, from our current point X. So, kukumputin natin ano yung cardinality ng open ball centered at X, the current point X, with radius epsilon. Okay, let's call this number n sub epsilon. So si n sub epsilon, siya yung kung ilang elements ng dataset ang within epsilon units away from the current point x. Okay. Now, we will go to a decision point. Okay. So if n sub epsilon minus 1 is less than theta, then x remains uncategorized. Possibly, it could be an outlier, right? Or it could be what we call a border point na hindi niya na-satisfy yung density. Kasi titingnan natin, yung number of neighbors ba ni epsilon, yung number of neighbors ba ni x within an epsilon neighborhood ay greater than or equal dun sa density. Right? Kasi kung kakaunti yung laman ng epsilon neighborhood niya, kaya kakaunti with respect to theta, the density that we set earlier, ibig sabihin, kakaunti yung neighbors niya, so ibig sabihin, hindi pa natin siya mako-consider to be a part of a cluster. So ibig sabihin, posible noise siya. Kasi yung number of neighbors niya ay hindi pa lumampas ng density threshold theta. So kakaunti yung neighbors niya, so let's set this aside for now. Okay? Now, otherwise, if it has a sufficient number of neighbors, pwede ko na siyang tawaging isang cluster point. So a cluster point is a point in your data space with a sufficiently dense epsilon neighborhood, right? When we say sufficiently dense, ibig sabihin yung neighborhood niya ay may laman na at least theta number of members aside from itself, right? And if that's the case, then we assign x to the class Ci. Okay? And then step number 4, we iterate over all y in the neighborhood of x until no new data is assigned to Ci. So after nating masabi na si x ay isang cluster point, titingnan natin lahat ng kapitbahay ni lahat ng nasa epsilon neighborhood ni x. Tingnan natin kung masasatisfy ba niya yung theta threshold. If it does, then it will belong to Ci as well. Okay. So pwedeng madagdagan si Ci, palaki ng palaki si Ci among the epsilon neighbors of y, right? Pero pag naubusan ka na, punta ka na sa step number 5. So choose an uncategorized x mula dun sa yung dataset. So yung mga either nasa noise pa siya or hindi pa natin totally na-consider. And set I to be equal to I plus 1. Ibig sabihin, gagawa na tayo ng bagong cluster. So yun yung ginagawa ng density-based clustering. Now, it has the power to identify what are the noise in the data. Right? So, kaya lang ang problema ay, mayroon tayong malaking problema rito. Kailangan yan dalawang parameters. Kailangan i-declare nyo yung radius epsilon at saka yung density theta. And like any other machine learning algorithms, parang walang madaling paraan para piliin yung mga parameters na yan. Okay? Now, pero there are some studies. There's a study by Sander and his peers, si George Sander, noong 1998. I don't know if there are more recent researches pa rin, pero yung mga binrowse ko na materials, ito yung sinasite si Sander. Sabi ni Sander, si theta raw ay pwede nating piliin to be 2 times the dimension of the data space X. Right? So kung dun sa case natin na iris measurements, so ang dimension ng ating measurements ay 4 dimension, right? Kasi meron tayong 4 na attributes na may measure. So pwede nating piliin si theta to be equal to 8. So ibig sabihin, kino-consider natin ang isang point to have a dense neighborhood if it will have 8 members aside from itself within its epsilon neighborhood. So this is a rule of thumb na usually ginagamit, 2 times dimension of theta. But it is advisable to use a higher value than twice the dimension of your measurement data if you know beforehand that your data is noisy or maraming duplicates dun sa data mo. Kasi kung meron kang duplicate data, twice sila mabibilang. Alright, so ayaw mong ma-overpower yung duplicates yung clustering. Now, the problem now is how we choose epsilon. So we want epsilon to be as small as possible. Pero it's a question mark how to choose epsilon. There are some studies that suggest that this could be found by looking at the distance or the average distance between the 2 times dimension of x minus 1 nearest neighbors. So parang ang gagawin natin ay tingnan natin, computein yung 2 times dimension of x minus 1 dun sa case ng ating Irish problem. So that means 7. So sa bawat point, kukomputein ko, hanapin ko yung 7 nearest neighbors niya. So kailangang i-run ko yung KNN algorithm with k equals 7. So para mahanap bawat isang point, hanapin ko yung 7 pinakamalapit niyang kapitbahay. I will compute the average distance between each of the points and its 7 nearest neighbors. And I will take the average all throughout the value of all possible x's. Then yung average na yun, siya yung gagawin kong epsilon. So medyo mahirap siyang i-implement. Okay? Now, I found a routine kay Matlab kung saan actually merong isang package luckily kay Matlab na nagko-contain ng isang function para ibigay sa atin yung estimate para kay epsilon. And probably that's the only thing that I'll be able to show you today. Okay. So unless mag-extend ako sa Wednesday, nakasapin ko si Sir Joms kung pwede ako mag-extend sa Wednesday. 1 meeting lang naman. Para ma-save din kayo dun sa presentation, ano? Para mas mapahaba. But anyway, let me share here. Okay, so let's see. DB scan. Okay. So again, so ilo-load ko yung data. So let me just clear everything up and close everything. Okay. So line number 1 loads the Fisher-Irish data set. And then halimbawa, okay, wag muna to. Explain ko yan later. Gamitin muna natin yung ad hoc na epsilon na pinili ko. Halimbawa, epsilon is 1.12. Then theta equals 8. Kasi nga ang dimension ng ating data mula sa Fisher-Irish data set ay 4. So 2 times 4, that's 8. Or if you want to make it more automated, so gawin mo 2 times size ng mess in the second dimension. So ibibigay niyo yung number of columns ng matrix mess. Tapos ito times yun yung 2, yun yung theta natin. For some reasons, I chose epsilon equals 1.12. So ito yung magsasabi, kukompute natin yung 1.12 neighborhood ng bawat isang point. Bibilangin kung lampas ba ng 8 yung number of elements of that neighborhood. And then we'll have the decision box depende dun sa sagot dun sa tanong na yon. And then the DB scan is intrinsic in Matlab. So you just need to call the DB scan command, pass into it as first argument yung measurement matrix, tapos yung epsilon, tapos yung theta parameter, and then the distance na gusto mong gamitin niya. So in this particular case, I want to start by looking at the Euclidean distance. And then I look at how the classification went on. Papaplot ko lang yung figure ng scatter plot, ng group scatter plot. But here, I'll be plotting the third measurement, which is the petal length, and this one, the petal width. or vice versa. Isa lang naman to dun sa dalawa. Okay. Now, if I run this, ang saya ng buhay kay Matlab, no? Kakunti lang yung pinoprogram natin. Now, you see this, all right, or palitin natin, mas maganda siya ng mas maliit. So, unfortunately, with this parameters, ang nagawa lang ni Matlab ay i-classify yung data natin into two. You see, meron lang siyang dalawang classification, blue and red. Blue yung nandito, which you know to be the setosa variant. Okay. Tapos dito, magkasama yung virginica at versicolor. Kasi nga naman, based on the data, ang hirap i-partition nung virginica at saka versicolor. Because hindi natin sinabi dito sa Irish DB scan kung ilang clusters yung hinahanap natin. Okay? So yun nga lang yung weakness nitong itong DB scan algorithm. Kasi nga, kinonsider niya na isang cluster ito kasi napaka-compact nitong cluster na to, and it is very much far apart from the other cluster. Okay, it's understandable that the DB scan algorithm is having troubles distinguishing between versicolor and virginica. Hindi niya nahati yung isang malaking cluster sa dalawang subclusters. Okay. Now, but this is basically based on the parameters that I fed into the DB scan algorithm. Ang epsilon ko ay 1.12. Ang mawawang epsilon ko ay 0.5. Remember, this is a distance between data points. So ito yung 4-dimensional distance. So ano yung laman ng 4 na components ng vectors na yon for each point? Yung sepal width, sepal length, petal width, and petal length. If I change it to 0.5, okay, meron siyang tatlong classification na nakuha, pero tingnan niyo yung labels. Group number 1 is the red one, which I know to be the setosa variant. Group number 2 is the yellow one, all right? Pero yung blue one, ang label niya ay -1. Ibig sabihin, from the point of view of the DB scan algorithm, yung mga blue points ay mga outliers. Alright? So, hindi siya classified. So, i-etcha-pwera siya dun sa classification. Now, let's see. Okay, pwera siya sa classification. And then you really need to play with epsilon and theta. Okay? So, let's see. Let's make epsilon larger. Say, let's give it a 2.5. Let's see what's the effect of that. Kapag masyadong malaki si epsilon, ibig sabihin, malalaki masyado yung epsilon neighborhoods na kino-consider natin. So kung malaki yung epsilon na neighborhood na kino-consider mo, this could be thought of as the radius between the clusters or intra-cluster. Tulad nito, isa na lamang na cluster yung nabuo ko. Kasi malamang, when the algorithm ran, okay, so meron akong point X, kinuha ko yung 2.5 neighborhood niya, mukhang lahat nag-fall dun sa 2.5 neighborhood. So that's why you want epsilon to be as small as possible, right? But again, this is quite an ad hoc way of doing it. Well, I discovered kanina lang habang naghahanap ako ng paraan paano makapag-estimate ng epsilon o ano yung ginagamit in practice. I discovered that there is an intrinsic Matlab command. Ang tawag ay cluster dbscan.estimate epsilon. Let me just comment this out. Eto. Pero kailangan yung i-download yung radio toolbox. Or sorry, not radio, the radar toolbox ni Matlab para magamit nyo itong command na to. Kasi parang ginamit ito sa radar technologies wherein you want to determine based on radar measurements kung isang object lang ba. So tinitingnan niya as clustering ay belonging to a single object or not. So halimbawa meron 2 torpedoes, tapos gumawa ka ng radar measurements. Kung magkalapit yung 2 radar measurements mo, ibig sabihin nagbe-belong lang yon sa isang torpedo. Alright, so parang ganun yung clustering niya. Points belonging to a torpedo or not. Kaya understandable na sa mas military toolbox siya nakalagay, dun sa radar toolbox. So if I will let Matlab compute this for me, right? So, tingnan natin. Let me run this. Okay. Sa dalawang groups pa rin niya nag-group yung na clusters, nag-group yung data. Ang ganda ng pagkaka-cluster nung setosa variant, ano? So, nandun siya talaga sa ilalim. Tapos, nag-group niya lang with some outliers. Ito yung second group. Tapos, yung third group ay ito. Yung outliers, yung mga blue dots. Kasi sila yung group -1. And here, the epsilon that the Matlab found is 0.7662. Paano niya yan kinompute? Actually, sinearch ko yung documentation ni Matlab. Probably I'll just share it with you. Or, dahil wala nang time, pwede niyong gawin ay i-highlight itong command na yan, right-click on it, and then click Help. Papakita niya yung description nito. Right. So, let me open it in browser para mas malaki. Okay. Bakit k-means yung pinakita niyo? I'm not looking at k-means. I'm looking at this one. Okay. There you go. I don't know what's happening. It's diverting me pero to the k-means clustering help page. Pero yun yung ginagawa niya. If you want to see what it does, you can just run this. Do not equate it to epsilon para meron kang graphical output. Okay. Makita mo rito yung graph, right? Maybe I will explain next meeting kung papayagan ako ni Sir Joms kung ano tong ibig sabihin ng epsilon equals 0.766 and how that value was computed. All right. So dito niya makikita, basically you can think of it as any data measurement below this threshold. Epsilon equals 0.766 are cluster points. Ibig sabihin, yung mga points na nasa ilalim ng epsilon threshold na yan ay nagbe-belong sa isang cluster. Well, everything above are considered to be outliers. Outliers. Okay. And maybe we can talk about this next meeting kung bibigyan ako ng time ni Sir Zomer. Probably 1 hour or so would be enough. And also, ibibigay ko na yung problem set number 3. Okay. Pero itatype ko na lang siya ng mas detalyado kasi I was thinking when I was typing it earlier, ay i-discuss ko siya today. Pero dahil wala ng oras, actually, meron pa akong isang program sana na i-share with you. 3 yung plan kong i-share sa inyo. Kaya lang, so I have the hierarchical algorithm here, which actually may dendrogram pa ako na ginawa. Alright, tingnan lang natin. So ito yung clustering yung nagawa. Actually, dun sa hierarchical clustering, you can tell Matlab how many maximum, what's the maximum number of clusters that you wanted to use. Bawat 3 lang kasi alam ko naman beforehand we have 3 variants. So pag niran ko to, makita nyo itong dendrogram ng grouping. Okay. Then we'll see this guy. So ito yung grouping niya into 3 clusters. And it seems that the hierarchical algorithm was able to rightfully identify yung 3 clusters. Right? Tapos ito yung decision tree o ito yung dendrogram para dun sa hierarchical binary tree. Right? Pero siguro more on that na lang next time. Then I also have the k-means algorithm. Right? Hindi ko ginawa yung y-test. Pero anyway, ito yung result naman ng k-means algorithm. Maybe I'll share it with you next time. So medyo edit ko lang siya ng konti and I'll make some description. Right. All right, so I should stop here because I don't want to keep you from having your dinners now. But do you guys have any questions, clarifications? I'll still need to talk with Sir Zomer about the requirements for the course. I'll be giving you the third and the final problem set from my part, so you can think of having 3 problem sets from me, okay? Now, I will bargain with Sir Jomar that if possible, sa January ko na ipapapasa yung problem set number 3, okay? At least yon sa January na para mabawasan yung mga kailangan yung i-prepare. Or meron pa ba kayong isa-suggest? Gusto nyo rin ba yung 2? Ako yung nahihirapan para sa inyo eh. Parang ang dami yung ginagawa.
Sir?
Yes.
Bali po yung problem set 1 ay yung
Yung exposition.
Apo.
Yes.
Tapos yung dalawa po yun.
Yeah, yun yung problem set 1, yung Kraut at saka yung Doolittle.
Apo.
Tapos yung problem set 2 ay yung regularization. Yung, ano ba binigay ko sa inyo? Yung backward heat equation ba yung binigay ko? O yung isa? Hindi. Yung regularization ng convolution, the convolution process. And then the third problem set will be, you will be exploring clustering and classification algorithms. I-share ko naman uli sa inyo yung code para hindi na kayo mahirapang mag-code. And I hope you downloaded the statistical and machine learning package kay Matlab kasi ang laking tulong niya. Kung nakita nyo kanina, di ba? Sana mamamanuhin nyo yung KNN, yung decision tree, pipili kayo ng mga parameters kasi ang gagawin ko dun sa problem set, i-ask ko kayo na mag-download ng data, whatever data that you want from the internet. So at least 200 specimen. Hindi na ako nag-specify kung ilang number of columns. Basta 200 rows yung data. Tapos bahala na kayo kung ilang columns. Tapos pipili kayo ng clustering algorithm. Tapos pipili rin kayo ng classification algorithm. Alright? So sana gagawa pa kayo ng confusion chart para sa bawat parameter ng mga classification algorithms. Pero thankfully na-discover natin na meron palang classification learner si Matlab. So pwedeng i-feed ko lang sa kanya yung data. Tapos ipa-optimize sa kanya yung KNN, ipa-optimize sa kanya yung Bayesian classification routine, ipa-optimize sa kanya yung decision tree algorithm. Siya na yung magbibigay ng best candidate on that classification class. So ang kailangan nyo na lang i-compare at ipakita yung evidence sa akin ay mas maganda ba yung optimal tree o yung optimal na Bayesian o yung optimal na KNN. Alright? So parang ganun na lang yung mangyayari. But before that, you need to do an unsupervised learning. So pwede kayong mag-hierarchical, mag-DB scan, at saka mag-K-means clustering algorithm. And then gagawin nyo siya with different parameters. Tapos papakita nyo sa akin kung ano yung pinakamaganda dun sa tatlong algorithms na yon. What parameters were the best. And then gagamit tayo ng, tapos pipili kayo ng clustering algorithm that will work best with your data set. But I will explain it more in the written questionnaire for the problem set. And hopefully next meeting, payagan ako ni Sir Joms para makita ko pa kayo on Wednesday. Okay? So other questions or concerns? Linisin ko lang yung mga codes kasi medyo nakakahiya pa siya. So lagyan ko rin ng mga comments para mas madali niyo siyang ma-decipher. Kita ko si Bemsor kanina nag-unmute. May tanong ka ba? Or
Okay na po, sir. Actually, yung suggest ko po sana, sir, comments about doon sa Matlab codes and nasabi niyo na rin po, okay na po yun, sir.
Right. So just give me tonight, hopefully, or over the weekend para mas maayos siya. Lalo na yung mga hindi natin na-discuss in details. But if you are more familiar with Orange, you're more familiar with Python, and you know the code for them, pwede nyo siyang gamitin. Hindi ko kayo nire-require na mag-Matlab. So yun nga lang, mas sanay ako sa Matlab. So kaya yun yung ginagamit ko pang demo. And I find it highly intuitive aside from Python. May bias kasi ako against Python. So kaya Matlab yung ginagamit ko. Pero kung may makikita kayong package kay Python, that's fine with me. Alright? So pare-parehas lang naman yan. Magkakaiba lang ng syntax. Alright? And what else? Piling ko papayagan naman ako ni Sir Jomar na arborin yung next meeting. Kasi nawalan tayo ng pasok nung bumagyo. So mababawi ko yan. Alright? para rin ma-move yung deadline nyo sa ibang problem set. So pag-usapan namin ni Sir Jumps over the weekend. Okay? So, other questions? So kung wala na, thank you guys for joining me today. Sorry, overtime na naman as usual. Oh, don't forget to answer the student evaluation of teachers in SAIS, ano, para makaganti na kayo sa amin. So, ang deadline niya ay ngayon, so December 9. So kindly answer that instrument. And with that, thank you guys. Enjoy the weekend. Hopefully, we'll see each other again on Wednesday, all right? Bye, guys.